Okay, so maybe I will go back. So in IoT enabling technologies, we have basically technologies such as embedded systems, communication protocols, wireless sensor networks, cloud computing, big data, enabling IoT systems, right? So these technologies are required to form, or I mean, they are crucial technologies for an IoT network, right? So first, we can talk about the embedded systems, right? So earlier also we actually discussed about embedded systems under the physical design of IoT. Right. In that case, we discussed about different controllers that we can use and like what are their specifications and their applications. Right. So uh, I mean, we require some microcontrolling at the IoT device level in order for us to send the data after collecting it securely at that microcontroller, right? The sensors itself cannot independently send the data. The sensors can only collect the data. The data that is collected from the sensors have to be like stored in the embedded systems in a like a suitable manner to be transported or transmitted across the communication channel, right? So in order for us to create the data packets and the data streams, we need to use these microcontrollers. Sensors will be connected to these microcontrollers. The microcontrollers will form the data like in a suitable manner to be transmitted to the local server. The microcontroller based hardware board will also be having control, I mean, communication modules, right? So communication modules like Wi-Fi module, Bluetooth module, or LoRa module, Zigbee module. Likewise, we can have different types of communication modules. So those communication will enable the communication in the I mean at the microcontroller based board, right? Hardware controller. So the embedded system anyway basically collects the data and prepares the data to be sent to the local server. So it has memory, it has input output interfaces, it has processing systems, it has its own processing speed. So depending on the board that you select, these specifications will be changing. So we need to be careful when we are using a certain board, if whether we are following the correct specifications, input output voltages, and whether we are connecting to the correct pins, or whether we are I mean connecting correctly the components or the sensors to the controller board, right? Otherwise the board will not function, it will burn, and you might have to spend a lot of money on buying new ones, right? Apart from that, embedded systems, like cost wise, some like currently actually embedded systems are getting cheaper, but in general actually they are kind of expensive, right? So therefore like this is one of the challenges in IoT systems, is that the cost of the embedded systems, right? The cost of these microcontroller based hardware systems, right? So I mean those boards, right? Hardware boards and sensors also cost a little, but sensors, it depends on the different type of sensor that we are using. Some sensors are small in size, and if it is like having materials which are abundant, then we can actually buy it for a lesser price. But some sensors are costly, and we might not be able to deploy a lot of sensors in our IoT network. Then we have the communication protocols. Earlier also, we actually looked into multiple communication protocols. So we actually looked into Bluetooth, Zigbee, MQTT protocol used in the application layer, cellular protocol, which is used for communication using wireless and wired mediums. And then we have Wi-Fi protocol, then something called OPC UA. It is actually an industrial protocol used in industrial settings, and the NFC protocol used for near field, I mean, communication. right? So Sigfox, it is also a communication protocol in the network layer, and Z-Wave, another communication in the physical layer, and LoRaWAN protocol, which is used in the network layer. So these protocols enable us to have the communication across the physical layer and network layer, application layer. So these protocols help the communication across the basic layers in IoT, which are physical and data link layer, network layer, application layer. So basically, and transport layer as well. So I mean, in transport layer, there's not much of a difference than TCP and UDP. The IoT specific protocols are basically introduced in the physical data link layer, network layer, application layer. So those protocols enable the communication to happen reliably. So we have discussed about these as well. Apart from that, now wireless sensor networks. So wireless sensor networks um, are networks which are also, I mean, composed of wireless sensors and nodes. So this is similar to IoT. So what is the difference between IoT and wireless sensor networks? Right. So the main difference, according to my knowledge, is that wireless sensor networks are like a subset of IoT networks, right? It is a less complex version of IoT networks, right? So wireless sensor networks are defined for tasks which are kind of homogeneous. Like for example, the sensors that are used in wireless sensor networks are mostly same. Like I mean, this might change in some situations, right? You might use different sensors, but wireless sensor networks, we are deploying the same type of sensors in a large area or a field, right? In this figure, you can see a kind of an implementation of a wireless sensor network, right? In there, we have sensors like spreaded in a certain field, right? Which collect data regarding that environment, right? So if we consider like a smart agriculture scenario, we use these sensors to measure the moisture level in the soil, temperature in the environment, humidity in the environment, and likewise, different parameters can be sensed from these sensors. So whatever the data that are collected from the sensors are collected by intermediate devices, right? Intermediate devices like it could be a local server, right? That the sensors send the data to, right? This R device could be uh, sensor server uh, which has the ability to collect and store the data, and from that place it will be transferred to another uh, device which can forward that data forward, I mean, which can forward the data further, and then likewise that data can go across multiple hops and reach a gateway device which can connect the data stream to the network, to the internet. So these I mean devices could be out of coverage, right? In certain situations, we might not have direct communication with the gateway. In that case, we will deploy these kind of intermediate devices which are capable of collecting and sending large amounts of data to another device in the neighborhood, right? So we will use relays, we call. So we will use relays like this, which can be routers across the area, and we will use these device routers to forward the data from one point to another point, right? So until it reaches the gateway, it will transmit the or forward the data uh, until the gateway is reached, and then once the gateway is reached, it will forward it to the cloud, and the user will be able to access the cloud and get the data. So therefore, I mean, wireless sensor networks are actually a subset of IoT networks. It's less complex than IoT networks. Most of the cases we have like sensors to collect and send the data to I mean, access point. So the sensors are only responsible for like collecting data and sending it to the access point that they can reach, and then the access point or I mean the server that collects the data will forward it to the other I mean device, right? So if a router is collecting the data, the router will forward the data to the next router, and then likewise it will go on until they reach the gateway, and then they will forward to the cloud. So basically the connection must be like maintained with the sensors. I mean, the sensors must be able to connect with the access point somehow. So the communication range of the I mean technology used must be enough to reach the server or the router in here, right? The access point must be reached by all the sensors in the area, right, that we are considering. So we need to consider about the communication range. So the communication range must will be determined by the communication technology we are using, right? So basically, once we are taking the technologies, if you are using Wi-Fi, for example, it is actually having high energy consumption, right? So therefore, it is mostly used for indoor communications and like short range communications, right? Apart from that, Wi-Fi also is not able to do like uh, long range communications. It can do up to maybe 1 to 10 meters of communication reliably. Bluetooth is also a good option. However, actually, Bluetooth also it is working for a like a short range, right? So therefore, although it is having low energy consumption, it has a short range. So therefore, it cannot be deployed in a situation where we deploy the sensors in a large area, a large network area. So therefore, we need to go for other wireless technologies, right? Apart from that, we have other technologies like LoRa, and LoRa is actually having like a higher communication range, right? It can also transmit a lot of data, so it can have high data rate as well. So therefore, I think it is a convenient solution for situations where we want to transmit up to 8 to 15 kilometers of range communications. So once we want to reach 8 up to 15 kilometers of uh, I mean communication range, we can go for this LoRa communications. Apart from that, Zigbee communication, once we take Zigbee communication, it has a range of about 1 to 100 meters, and it has a low energy consumption than LoRa actually. So I think it is a good option once you have 1 to 100 meter communication range, right? Uh, So actually, ESP32 cannot function as a router. So ESP32 can send the data to a router. It can connect with the Wi-Fi router, but it is not functioning as a router. So it is not performing the routing functions. Apart from that, so I think Raspberry Pi also is not acting as a router. So we need separate routers, like access. I mean, router. I mean, the function performed by routing. We need to access. We need to obtain routers in order to do that. So, according to my understanding, the microcontrollers itself are not sufficient to do the routing. So you can't. I think you can't use Raspberry Pi to do the routing. The reason is that routers are configured beforehand to understand where the other routers are and forward the packets by like checking the routing tables and doing the functions that they do, like so routing function, so that must be configured beforehand in this route, I mean in this device. So if you can do that function, if you can actually install routing function in a like a microcontroller board, then you can use it as a router. But currently I think inside the small storage of microcontroller boards, I think Raspberry Pi is having high like processing power and high storage, everything. If you can like program it to work as a router, if you can install the networking function there, then you can use it as a router. It's totally fine. But ESP32, um, it is I think it is, I mean as of now it is having limited capabilities of doing processing in terms of doing routing. So it can do storage and like other like data like processing and all, but up to a certain limit, and I think it will not be sufficient for the routing function. So network routing also can be software, I mean can be defined as a software. So if it can be installed in the Raspberry Pi, then you can actually use it as a route as well. However, please, you need to check on that, whether it can do routing, right? So currently, Raspberry Pi is doing most of work such as like high complex computations at the IoT edge level, where it will, do image processing, for example, take images from the environment and do machine learning. Even sometimes it can actually do some up to some extent, or like high definition, high complex tasks. However, you need to check whether the network routing function can be done or not. Right, so if you can install it as a software, then you can. So afterwards, the wireless sensor networks will basically do this collection of data, monitoring of the data, and communication of the data. So wireless sensor networks monitoring of data means that it will sometimes not send the or unnecessary data, right? Or else sometimes it will get like on and off, like it will have some sleeping modes and active modes, right? So the wireless sensor networks have this option of saving energy um, while while functioning in the network, right? So this is one of the important things, this having active modes and sleeping modes, right? So that is also one of the differences between IoT and wireless sensor networks, that is like energy consumption of the sensors are lesser than the IoT systems, right? So the sensors are like designed in wireless sensor network to consume less energy, right? The reason is that there's wireless sensor networks cannot be deployed in large areas without providing constant energy, right? Constant battery power to these network sensors, right? So we can't connect energy like providing batteries or something to every sensor that we place. So we try our best to like harvest energy from the environment, right? And like do the tasks at the sensor levels, right? So we use like nowadays we can use energy harvesting techniques, right? Different energy harvesting techniques have been proposed by research works and all. So from solar we can take energy. Apart from that, from ambient backscatter, or like from the ambient light, in the normal atmosphere, from the light that we have, from the light signals we have, we can store energy. So we have now technologies to store energy using visible light technology, right? So one of the main concerns in wireless sensor networks is that the less energy at each sensor level. So therefore we need to come up with energy energy storage or energy consumption. We need to plan our energy consumption at these wireless sensors correctly, or otherwise our sensor network will not be able to function correctly. Apart from that, we need to use these sleeping and active modes to on and off these sensors from time to time, such that their energy is saved, right? Only at one time they will take the data in the environment and they will sleep. They will send the data to the access point, they will sleep. Likewise they will work. So likewise we need to plan the energy consumption of these networks, I think, more than anything else in these wireless sensor networks, right? So energy consumption must be taken into consideration as a main factor. Apart from that, these wireless sensor networks are able to organize based on the environmental and network conditions. As I said before, if it is sensing that it is consuming more power, it will switch off or sleep, and after some time they will on. Apart from that, based on the environmental energy it has, it will harvest energy. So likewise, based on the environment, it will also react, and it will function right? It will function suitably, right? Apart from that, cost effective, scalable solutions, right, must be there to collect the data, right? So actually cost effective means we need to place the sensors in a like suitable manner, such that we can spread all the sensors in the area like optimally and collect the data uh, suitably, right? So uh, then wireless sensor networks, in wireless sensor networks we call the sensor based processor plus communication module a node. So we use this term to denote all the entire unit, the sensors, communication module, and the processing unit. So all these components we call as a node, right? Inside the node we have all these components, and these nodes are actually designed to be very small and also work on their own, right? We have programmed them beforehand. So based on that program and based on that algorithm that is written in the processor, they will work on their own. We don't have to intervene, and we don't need to monitor them all the time manually. We don't have to configure anything. Autonomously, automatically they will collect the data and send the data to the server. Then resource constraint, right? So processing, right? So the energy at the sensor node will be less. Processing ability will also be less in situations where we have the sensor or the processor having less ability for processing, right? We cannot do a lot of computations, right? So like Raspberry Pi, for example, it has a lot of high computation ability, but we can't use specifically Raspberry Pi at each location in the wireless sensor network, right? So in the wireless sensor network, we might have to go for cheap options. In that cheap option, we might not be able to do the processing in a complex manner. So therefore, we don't have processing ability, like high processing ability. And then storage also will be limited. We might not have a lot of storage at each sensor node. Therefore, we will collect the data and we will send the data as soon as possible to the server. And a communication range, it will depend on the communication technology that we are using. So based on that, we need to plan the wireless sensor networks, and we need to know the limitations of the communication and the network. And then design, most of the sensors are designed to be energy efficient. So as I mentioned before, energy is the most important parameter in wireless sensor networks. apart from the communication and sensing, right? The energy must be saved at the sensor locations, otherwise the sensors will not work and then they will not be able to send the data. Right, so if you have any questions, you can ask. Cloud computing, right? So it is the next technology that will enable the IoT networks, right? So cloud computing is basically regarding the computations that will be done at the cloud, right? So what is the cloud, right? So the cloud actually is a storage that is there, that is they are in like data centers which are connected to the internet, right? So the internet has is a connection of multiple networks, right? So internet uh, has the connection to a network which has servers, data centers with servers that have the storage storage facility and the processing facility, and likewise the main complex computation ability is there at the cloud based servers, right? So basically cloud is providing storage and computation of data. So once we have data that we want to once we have a lot of data, we can send that through the internet to these cloud based servers which have a lot of space in them. I mean, these are actually these cloud servers belong to big companies and they maintain these cloud servers. So inside the cloud servers, they give us a small space or a certain amount of space for our usage. So once they are giving the space, based on the space that we require, that we request, they will charge us, for example, right? They will give for free for some amount of storage. Apart from that, if they give more than a specified limit, they will charge us for that, right? So so multiple companies like Google, Facebook, YouTube, they have uh, cloud servers running which collect the data in their companies, right? Whatever the data that are getting stored or collected by those companies in their applications, in their softwares, their different tools, they keep in these servers. And then once it is needed, they will give to the customers. Apart from that, if they want to do some analysis on of the data, they will do that using the supercomputers that are available in these servers, right? So there's supercomputing ability available in the servers, right? So therefore cloud is a resource that enable us to store the data in that and do some complex computation. This is something that we can't do in local servers or local computers, right? So you can't do like huge data related computations at local computers. Therefore, it is beneficial for us to send that data to a cloud server and do the computation there for a low cost. And also companies prefer to use this method mainly because they don't have to manage the infrastructure or something. The cloud server company, the provider will do that for you. So therefore, cloud services are getting, are popular between the companies now, and people hold their companies in clouds. So therefore, the cloud computing technology has become a trending technology, and IoT systems also require this cloud computing technology to store data and do the computation, right? So the companies which are like popular for IoT, I mean, based cloud computing, IoT based cloud computing, Google, right? Microsoft, Amazon, Cisco, and so on. So they are actually focusing on IoT as well, right? Amazon, Cisco basically are having their like infrastructures focused on IoT systems specifically. So in this course as well, I'm going to like focus on Amazon IoT as well, and maybe going through some of the concepts that are there in Amazon IoT, and also like what are the different standards and policies they are following in their systems, and what are the like functionalities that are there in their system. So it's actually very I mean user friendly as well. So you just need to follow certain set of procedures to connect your device into their I mean cloud computing infrastructure, right? Once you have IoT devices, you can install them and you can send that data to the cloud server, right? Apart from that, they are also using protocols such as MQTT and all, so that you can I think you can actually use that system to like do all the work that you want in your IoT system. Like, however, sometimes the prices will be added to the service they provide. So sometimes they might not provide it for free. However, it is an infrastructure that enables us to that gives us all the services related to IoT, for example, from managing the data until the analysis of the data. They will do all the collection of data and storing the data, securing the data, and so on. So if you're going to use, for example, Amazon IoT, you don't have to worry about the security of the data, for example, management of the data. If something goes wrong, you can refer to Amazon IoT and you can like ask from them if some error happens. So those kind of tools you can use for IoT systems. So basically in cloud computing, we will be uploading the data to the cloud for storage, analysis, and for accessing those data in a remote manner. And once we have massive amounts of data from, especially once we are considering IoT scenarios, we have massive amounts of data. So once you have massive amounts of data, you can send that to the cloud, and you can do the cloud computing. Apart from that, cloud computing offers the scalability, reliability, and the computation ability for the IoT processes. Right? So the scalability is a good factor because IoT systems will I mean will consist of multiple sensors. So once we keep on adding the number of sensors, we might need to scale the system up. So once the number of sensors are increasing, we will scale the system. So the cloud will be able to adhere to that scalability. It will also reliably keep our data like without destroying or modifying the data. Apart from that, it will also do some computations on the data that is collected. So in cloud computing, we have basically like three types of key service models. So we have software as a service. So in there, actually, I mean, the cloud servers, they provide us softwares such as Google Drive, email, and maybe even games that can be used by us by accessing the cloud. And we can do the like tasks in the cloud, and we can save our data in the cloud itself. So in the Google Drive, for example, we have different functions that we can perform for editing our documents, and likewise we can do a lot of tasks. So that software will be available to us through the cloud, and we can use and we can store the data in the cloud. So then we have the platform as a service, which is known as PaaS, and the platform as a service enable us to use the platform as a tool that can do web application developments, and which can do, for example, database management, and like small tasks, like one specific task, like network management and so on. So specific tasks can be performed at a a certain platform, and different platforms are there are for different applications, different functions. So such kind of platforms are also provided by the cloud, so you can use the resources in the cloud. So apart from that, infrastructure as a service. So infrastructure as a service uh, is a service widely used by big companies who want to deploy an entire infrastructure in the cloud servers. In the cloud servers, every like function that those companies want to do are stored in the cloud server as a function. So each function, for example, like providing services to the customer, and between company like people who are working, and then doing the storage of the data, and I mean collecting and storing the data, doing the networking between the data, uh, I mean networking between the customers and the organization, and then securing the data and managing the data. So all the functions that are required by a certain organization will be done by the infrastructure as a service. So infrastructure as a service, we can take, for example, AWS, Google, and likewise like Microsoft. So we can, I mean, deploy a entire infrastructure in the cloud server, which can do like all the activities that is required by the company for its workers and its clients. And then we have big data analytics, where we talk about large amounts of data, right? So in IoT specifically, we are collecting large amounts of data at the edge of the network. So we keep on sending the data to a certain access point, right? So the access point will be collecting all the data that is collected, right? So in situations where we are monitoring the environment, for example, we might need to collect the data like frequently, not like in hours. So we might need to collect data every 5 seconds, for example. So in that case, we might, if we, I mean, we might have a lot of data at the access point if we have a lot of sensors. And then that big data needs to be sent to the cloud server, and then do the computations there, right? So once you are doing the computations, sometimes you can observe that the data that you have collected has maybe duplicates, right? Or some missing data are there, or some error data, like erroneous data are there. So sometimes we can see like some data are not believable. We can't believe that that data has happened. So it can, like if it is like, for example, like weight of something, or some moisture level or something, moisture like content or something, if it is minus, sometimes it might not be correct. So likewise, depending on the parameter we are measuring, if we see that the data is containing some error values, like some values that we can't believe uh, could be the measured value, then we need to do the like analysis or cleaning of the data first, right? So first we need to I mean get the data collected, right? So if we get the collected data at the cloud server, for example, then we will be doing data cleaning, cleaning of the data, as I mentioned before, where we'll be removing duplicates, and we will understand there are some missing data, and also we will remove erroneous data. Then we will use the correct data, or whatever the clean data available, to understand the data using data visualization. So we will be able to observe patterns that the data is showing with like time, for example. So if we collect data regarding soil moisture level, for example, we will be able to see some pattern of the moisture level along the time. So data visualization means like observing the pattern of the data. Apart from that, in data analysis, we can go further ahead, and we can see whether that certain data is following a certain like a threshold or something, right? If the moisture level goes below a certain threshold, we can like decide that the moisture is not enough in that environment. Based on that, we can allow more water to be supplied to that network area. So based on the data that is collected, making some logical analysis of the data and then making decisions will be done at the data analysis stage. And also making decisions like we need to give more moisture to the soil, and giving that feedback back to the network will be done as a under data analysis. So in the data analysis, we'll be giving some useful data. So maybe we give the feedback to the farmer, for example. So the farmer will be notified about that via a mobile application, for example. Apart from that, the data also can be notified to the sensors, where the sensors will be, sorry, I mean water providing sensors, or like pumps or taps or something that are connected to the moisture areas. They will be moisture providing systems, water providing systems. They will be activated based on the feedback received by the IoT system. So that is how an IoT system will be designed, right? So therefore, IoT system is basically able to make decisions at the cloud server, and do like computations there and give feedback to the user, for example, where the user will take some actions on the data collected. Next, we will be looking at the IoT levels and deployments. Uh, so IoT deployment can be categorized into different levels. Depending on the deployment and depending on the complexity, the cost and the scale of the implementation. Basically, these kind of levels can be different numbers. So in the Google, once you search for the number of levels, sometimes it will tell different values. Some have defined IoT systems to have maybe 3 levels, right? However, this is from the reference book that I have mentioned before for this course. So they have they are mentioning about 6 levels. So I will be following that concept, and we will be discussing about the level 6 of 6 levels of IoT deployment. So we'll be having 6 levels depending on the complexity, cost, and the scale of the implementation. So in level 1, we are having the basic architecture. So the most basic architecture is there in level 1, right? So in level 1, we have a sensor node, which can be denoted by these 3 components, where sensor node is having a certain, for example, sensor node is a certain device. It is having some resources like for storing data, for computing, doing some computations of the data. And then also they have a controlling component where it will control like what data needs to be sent to the database, and what data will not be sent. Likewise, there can be some microcontroller which will be doing some controlling of the data that will be sent to the access point. So once that data is sent to the access point, right, so the data will be sent to the to a mobile application which is available in the local server, right? So this part we can actually consider as the local server. So the sensor will send the data to the local server, which will constitute of database and also constitute of REST plus WebSocket services, which will provide us the interface to access the web application and give the data to the web application, right? So the web application will be able to be accessed using this REST and WebSocket communication, right? So the REST and WebSocket communication like are based on REST and WebSocket protocols, right? So we actually these are we referred them in the previous lessons. So the REST protocol basically uses certain like functions such as get method, put method, post, delete. Right? Uh, uh, we call these as request methods. So these request methods are like standard methods that are used by a REST protocol. So these request methods are used by the REST protocol to access a certain resource, or modify a certain resource, or delete a certain resource, and so on. So the REST and WebSocket services are required for the database to connect with the application. So the database will be accessed by the application, right? And I mean, sorry, the data will be stored in the database, right? So once, for example, once a customer is there, that person will access the app, and uh, once the app is getting commands from the person, it will use these REST protocols to access the database data. Or else it will use the WebSocket protocol to access the data, right? So we actually went through the WebSocket protocol as well. So these REST plus WebSocket services will be used by the application to access the data in the database. So in this level of deployment, we only have a very simple implementation, very simple like deployment. In there, we will have like maybe one type of sensors, or like small number of sensors in this network, and there's no big data. That means like not no large amounts of data collected, only a small amount of data is collected, and simple computations will be done at the some simple computations will be done at the local server, if there's a server, and the database will be basically collecting the data and sending the data to the app. So there would be showing of data, but not much of computation. Then low cost of implementation. So therefore, we don't have to spend a lot of money to implement this system. So in this system, we can notice that these local, level one IoT systems are limited to the local server, and doing all the work inside this local network, right? Only in the local network, this IoT development is done. The cloud is not as taken as part of this. So we are not sending our data to the cloud. We are not doing storage of our data in the cloud. We don't do analysis there as well. So therefore, we don't have much complexity in this type of IoT implementation, right? So we are limited to the local area network. Um, so one of the applications of the IoT level 1 implementation is that we can have smart home automation using IoT level 1 deployment. Right, in that case, we have sensors. So we can take sensors like we can take washing machines and uh, other equipments, vacuum cleaners, AC, fridge, and so on. We can take different measurements from those appliances, and they will be accessing the Wi-Fi. Through the Wi-Fi, they will access the local server that will collect the data and store the data. That local server will be accessed by this smartphone. The smartphone will be able to access the database using the application that is built for this smart home automation. It will use these REST and WebSocket services to access the data in the database. Right. So I hope it is clear to you. Next, level 2 deployment. So in the level 2 deployment, it has a bit more functionality or complexity than the level 1. In there, we have an integration with the cloud. Right? So our data that we collect at the sensor level will be sent to through the local server to the cloud, right? So first the cloud will be accessed through REST and WebSocket services, And after that, those data that we will be sending will be stored inside the database, and the data will be modified and created and obtained using the REST WebSocket protocols. Then the data will also be accessed by the application that is run in the cloud, right? So the application can be built in the cloud. So some software that we can uh, develop in the cloud can be used to access the data in the database. So this app can be accessed by any person who's accessing the cloud as well. So apart from that, the app will also use this REST and WebSocket communication protocols to access the data. So in this level of deployment, basically we are doing the storage, uh, data storage in the cloud. That is the main difference between the previous level 1 and this level. So the data will be stored inside the cloud. However, in this case also, there are no complex computation done at the cloud. So there's no analysis done at the cloud. However, we are basically sending or storing the data that is collected. So in this case, we are having the cloud as a support, as enabling technology. So as I mentioned before, cloud is able to store large amounts of data. So for situations where we are like measuring big data, we can collect big data at the sensor levels, and we can send to the cloud storage through our local access points. And using these REST and like WebSocket services, we can send our data to the cloud storage. So this is used basically in situations where we use big data and simple computations are required. So a lot of analysis will not be done. Basic computations will be done. Basically, small computations can be done. Apart from that, based on rather than the first level, we have a database and application hosted in the cloud. So one example for this deployment is the irrigation system. So smart irrigation system that can be deployed by the use of the cloud. So we collect the data, we connect to a access point using Wi-Fi, Bluetooth, or maybe LoRa or some other technology, right? Cellular technology also we can take, and we can connect with our local server. The local server will send all the data to the cloud-based storage and cloud-based application. The database data will be accessed by the cloud-based application. So this is an example of the level 2 deployment. So in that case, actually, we did not do much of complex computation at the cloud. We just show the data at the application. Next, in level 3, we will be deploying the same network as before. The only difference is cloud storage and analysis will be done. So analysis of the data will be done in this deployment. So apart from the data collection, we'll be doing some analysis using machine learning, complex computations, right? So machine learning is an emerging technology that is available, that is coming up in this new era. So machine learning can use its techniques to predict the outcome of certain processes and make some useful decisions about what is going to happen in the upcoming future, right? So therefore, uh, uh, the machine learning is used for prediction of certain predicting of certain events occurring in the future, for example. And the complex computations can be done at the cloud. Therefore, we can do some useful computations at the cloud. We can give a lot of information to the user, right? So one example for this would be this like tracking of package delivery, right? So if you are using, for example, sites such as Amazon, eBay, like I think even Daras. So these technologies have like systems to track the delivery of parcels like from their storage houses to the homes. So once they are delivering those packages, they can inform the customer about the location of the parcel or the package. So they will have certain like a website or some kind of interface which will notify the user about the real-time location of the data package, right? So they will say, okay, it's at the storage, it's still going on, and finally it has reached the destination. So all these real-time monitoring can be done uh, because of the analysis done at the cloud. So if we don't do analysis at the cloud, we will not be able to say in what location this data packet is there, sorry, package is there, and inform the user about it. If you only collect the data at the cloud storage, then uh, the user will be able to see the data getting collected regarding the location. However, analysis like what is the time remaining to deliver the packet, and what is the location exactly of the package, those things I think need to be done using analysis of the data. Uh, so then we can talk about the level 4 deployment of IoT, where we have like a more complex system than the previous level. So in here we have an architecture like this. So we have like we can consider this as one sensor node, and this is another sensor node, and we collect data from these sensor nodes. So all the data will be sent to a like a local server. At through the local server, the data will be sent to a cloud-based database and application, right? So this architecture we had earlier also, right? The new thing that has come is these observer nodes, right? Observer nodes are like components which are available in local networks and also in the cloud networks, which are able to monitor the data that is collected in the database and like with the current status of the data. So so the observer nodes can monitor the data that is collected in the database. So in here the data will be collected and the data will be shown in the app. So the observer node can access the application and through the cloud, and then view the data, or else it can also access the database also if it is given the authorization, and it can access the data as well. Apart from that, there's observer node in the cloud that can be used to also monitor the performance of each of these systems. They will be able to monitor the performance of the application and monitor the performance of the database, database and the management of the data, and also functioning of this architecture. So the cloud-based node also uh, can actually monitor the performance of the different components in this architecture, right. So different to the previous one, these observer nodes are there in addition to the previous level of deployment. Apart from that, we can consider these observer nodes as subscribers as well, right? So people who have subscribed to this service that we are providing under a certain IoT application that is in consideration in this scenario, right? If you are considering a certain scenario, we can consider that we are providing some service to a certain customer using this collected data, right? So if we take for example, we will consider the example next. So whatever the service we provide, the subscriber will be able to access that service through the cloud services, cloud application, and they will be able to see the data. So in here also machine learning and complex computation is done. Then we will take an example for the IoT level 4, where we can consider situation of pollution monitoring, right? So in situations where we want to check the pollution in the environment in terms of carbon dioxide level in the atmosphere, the users who have subscribed to this service will be able to observe the carbon dioxide level in the environment through the application that is available in the cloud. So therefore, that is how the sensor-based measurements are useful to the observer node. And so basically, as I mentioned before, the observed nodes can monitor the data that is collected, and based on that, they can actually make decisions. Apart from that, in level 5, we have a higher complexity than level 4. Okay, so in this case, like, what is the difference? Right, so the difference than the previous one is having this sensor nodes, plus there's a like specific node which is called as a coordinator device. So the coordinator device is a common, a device, like a node in the network that collect all the data from the other sensor nodes, right? So this node 1, node 2, until node n, we can have number of nodes. All these nodes are sending their data to this coordinator device or coordinator node. So the coordinator node has to collect all the data, and that device will connect with the local server, and using the local server, they will connect with the internet. So after connecting to the cloud will store the data that is sent by the coordinator device, and will show the data across the app. So the only difference that we have with the previous architecture is having this coordinator device. So the coordinator device is having some problems in here, right? So can you explain to me, like, what are the challenges faced by the coordinator device in terms of the data collecting? Can you tell me one of the challenges, or any challenge that you think that coordinator device might face in this situation? Right, no challenges faced by the coordinator node. Coordinator node is very fine with collecting all the data from the sensors for a large amount of time, and then sending the data to the cloud. Is there no like energy consumption at the coordinator node? Is there no complexity at the coordinator node? What about the network traffic? Right, so the coordinator node, right? So coordinator node has to do multiple tasks in this scenario, which include collecting the data from all the sensors, collecting data from the all the sensors, right? So this is a not a practical solution for examples where we have multiple nodes. Once we have thousands of sensors collecting data, then sending that all that data to this coordinator node will like flood the the or else like congest the network at this coordinator node position. So the coordinator node will receive data without much break, or without much pause, right? So once we have all the sensors sending data to the same device, that device might lose some packets of data. We might run into losing some packets, which will not be good for the uh, reliability of the IoT network, right? So we need to maintain good reliability of the system. So reliability means like not losing the data, and also giving accurate data, right? So we are trying our best to give accurate data, remove the errors in the data, also not lose the packets. So therefore, we need flexible systems to adhere to the data that is collected from the sensors. In this deployment, once all the sensors are sent into the coordinated device has to send all the data to the cloud. The coordinated device has to store the data, send the data. So it is going to be busy all the time. So it is going to lose a lot of energy, and we need to focus on the coordinator node importantly to give enough energy to that node. So this deployment, the coordinator node is facing some challenges. And then we can go to an example of this scenario where we deploy this level 5 IoT. So in this case, we can consider a situation where we collect data about environment. So in forest fire situations, we can use this IoT level 5, right? So once a forest fire occurs, the sensors which are placed in nearby locations can sense those the starting of the fire and give the messages to the nearby nodes, which will forward that data to the gateway device. So the gateway device could be edge router, or it could be the base station, right? So it could be the base station or the edge router. So that device will collect all the data that is coming from all the sensors. If it is a base station, yeah, it can handle a lot of data for a long time of period because it is always switched on and it is powered by its own power supply. However, in situations where we have edge routers which less energy storage and also less battery power, then we might not be able to use a edge router to collect all the data from the sensors. So based on the application, we need to select the coordinator device. The coordinator device wisely such that the coordinator device is able to handle all the network traffic that is coming from the like massive number of sensors which are connected to this which are connected in this IoT network, right? In IoT networks, we have like massive number of sensors, right? So that is the example for the IoT level 5. Next, we have IoT level 6. IoT level 6 is basically the kind of the complex version of, which is having the higher complexity when considering to other deployments. So in here, what is the complexity or what is the advancement before the previous one, right? So in here, like can you tell me like what is the difference between level 5? What is the component that is added than previous deployment? Can you hear me?
Yes, ma'am, we
Observer
can
nodes.
hear.
Yeah, observer node was there in the level 4 as well, right? So we saw in the level, I think level up from starting from level 3 only had this architecture. Level 4 has the observer nodes, right? Observer nodes were there in level 4.
The centralized control.
Yeah, the centralized controller. Okay, so in the level 5 we don't have the centralized controller, right? There we have the coordinator device. We don't have a centralized controller, right? So the difference between the previous level of deployment and this one is basically the centralized controller, right? So this is actually very important difference that we see in the deployment. So in here, the centralized controller is a device or like a server or like a local server which provide control decisions, right? Server which provides some control decisions for the communication between the sensor nodes, right? Sensor nodes will communicate based on the commands given by the centralized controller, right? The sensors will send the data. Data will be sent by the sensors, but the data will be sent according to the commands given by the centralized controller. So what do I mean by that? So the centralized controller will decide at what time, at what frequency, what modulation scheme is used. And those, whatever the parameters that we define for the communication will be defined by the centralized controller. So centralized controller is therefore a very intelligent like a server which makes the like communication based on the network situation. First, the network situation, network topology will be understood by the centralized controller. Centralized controller knows how the devices are connected in the network, like what sensors are there in the network, how are they connected, if they are connected in multi-hop situations, right? How are they, I mean, connected to each other, like what is the nearest sensor node to the access point, so on and so on. It will have the global view of the network topology. Based on that, it will make decisions. What is the best node to first send the data? Then what is the next node to send the data? It will also take some like information from the sensors as well. Sensors will also send their status to the centralized control. Centralized controller will get updates from each of the sensors, and then based on those updates and whatever the information it has about the network topology globally, it will have it will have a good knowledge about the network, and then based on that, it will make the communication happen smoothly by each of the sensors, each of the devices, sensor nodes, right? So the data will be sent by the sensor nodes to the local server and to the cloud after, I mean, getting the command or following the commands by the centralized controller. So the centralized controller will be, I mean, just sending the control commands. Data will be sent by the sensors directly to the cloud servers using the normal routine they followed to access the internet, access the network. Then the data will be stored in the database and so on. The rest of the architecture will be same as before, right? So in here, the difference is having the centralized controller. Right? So centralized controller is used to improve the flexibility of the communication and reduce the network packet losses, and understand the faults that are happening in the network and manage the faults once they're happening. And if there's a fault, like what is optimal route to send the data along. Likewise, uh, it will have ability to uh, send the data optimally from the sensor node levels to the cloud, right? So likewise, such kind of intelligent work will be done here in terms of the network, I mean deployment and data communication. Those are the basic levels of deployment in IoT. So this is an example of the IoT level 6, where we are collecting data from multiple sensors in a, for example, a weather monitoring station. So in a weather monitoring station, we have different sensors to collect data regarding different aspects of the environment. So the amount of time that the sensors will take to communicate with the access point, what is the parameter they need to use, what are the parameters they need to use, those will be decided by a centralized controller. A centralized controller will ask them to send the data at a specific time using specific frequency, such that data will be sent very reliably to a certain local server and this local access point, and from there onwards they can the data will be reached to the internet and thereby to the cloud. So we have gone through the IoT levels and deployment, and so we have now we have to go through domain specific IoTs. So these are basic understanding I think you already have. So IoT applications are deployed in different domains, and IoT is already applied in most of the developing countries. We have IoT systems deployed for different applications, right? So in smart homes, they have IoT systems for different applications and for updating the status of different appliances in the system and so on. Apart from that, in universities, companies, they have IoT systems to monitor the environment and also monitor, for example, services. They actually use laundry services and washing, drying of clothes using IoT systems, and smart parking systems, smart lighting systems. These things enable those countries to monitor the appliances. That's one thing, and also save the time of the people the people can watch the whatever the IoT platform, and then they can get an idea about the situation at a remote location. Based on that, they can make decisions about when they are going to do a certain activity, or whether they are going to certain place or something. Like, for example, if they are having laundry service, if they are accessing laundry service, if they have IoT system for accessing the laundry service, then they know like which of the laundry washing machines are available, and at what time it is available, and how many customers are using that system currently. And like, once you have used the service, what is the deadline, at what time you can get back the clothes, like us. And likewise, we have applications in multiple domains that will uh, benefit the citizens of that country. So multiple countries actually benefit from these services in terms of saving time and cost for a certain activity. If you take lighting systems, the lighting systems have saved a lot of money. Why if with IoT, lighting systems with IoT has saved a lot of money compared to manual lighting systems, where you switch on and off manually. So countries have benefited very, very much using these kind of smart systems, right? So basically, that is regarding the domain specific IoTs. So we have different applications in different domains regarding IoT systems. So this is one video regarding that. So I hope I will be able to play it. I will. Okay, so I will go here directly.